How's it grade 11s? Okay, so we're still continuing with the trigonometric functions and identities. I'm moving on to the second lot of examples here. Okay. So these ones are different from the other ones, and I'll show you now why. So we've got e.g. 2a. So the question is prove the following identities. So we've got 2 cosec x and sin x over 1 plus cos x plus 1 plus cos x over sin x. Okay, so what these three little lines mean, it just means equivalent. So basically what we can do is we can say that this thing is this thing, okay? We can use either one, all right? So when we get ones like this, what we have to do is we have to prove that left-hand side is equal to the right-hand side, okay? So on the left-hand side here, we have 2 cosec x. Now remember, change everything to sine and cos. So cosec is going to be equal to 1 over sine. So we get here 2 over sine x. Okay, so if we can prove that this right-hand side is equal to 2 over sine x, then we've proved it. Cos x over sine x. Okay, so let's start working with the right-hand side now. So we're going to use an LCD, and our LCD in this case is, I'm just going to put it on the side here. LCD is sine x 1 plus cos x. Okay, so equals, this whole thing is going to be over sine x 1 plus cos x. Now this one's got a 1 plus cos x, so it just needs a sine x. So that's going to become sine squared x. This one has got a sine x, so it needs a 1 plus cos x. So we've got here up at the top, we've got 1 plus cos x multiplied by whatever our LCD was, which is the 1 plus cos x. Okay, so here we get sine x squared plus. So now I'm just going to FOIL this out, and we get 1 plus 2 cos x plus cos squared x all over sin x 1 plus cos x. Okay, so if you have a look here, grade 11s, we've already got the sin x at the bottom. So there we've got sin x, and there we've got sin x. Okay, so we're almost there. What I need to do in order for this to be equivalent is I need to cancel this 1 plus cos x at the bottom. Also, I need to get rid of all of this stuff at the top, and I'm just left with a 2. So if you have a look here, we've got that this and this is our square identity, because we know that sine squared x plus cos squared x is equal to 1. So those two things there will be equal to 1. So what we'll have is we'll have those two become 1, and then we have plus 1, so we get 2 plus 2 cos x up at the top, right? All over sin x 1 plus cos x. Now, up at the top, I can take out a common factor of 2, and I'm left with 1 plus cos x all over sin x 1 plus cos x. These will cancel, and we're left with 2 over sin x, which is our left-hand side. So this is equal to our left-hand side, and we have proved that identity. Okay, I'm going on to example B. Okay, example B is saying, just get it here. Example B is 10x minus sine x over sine cubed x. And this we need to show is equivalent to sec x over 1 plus cos x. All right. So I'm going to break it down, left-hand side, right-hand side. All right, so you remember what we need to do, change everything to sine and cos. Now, I'm going to start working with this right-hand side. It doesn't really make a difference, grade 11s. You can start with whatever side you want. So sec becomes 1 over cos. So we get here 1 over cos x, okay, divided by 1 plus cos x, okay. So remember, we tip and times this, so we get 1 over cos x multiplied by 1 over 1 plus cos x, and that will give us 1 over cos x, 1 plus cos x. Okay, so if we can show that the left-hand side is that, then we've proved it. So, tan x, change it to sine and cos, so that will become sine over cos. So we get sine x over cos x minus sine x. This was all divided by sine cubed x, okay? Find an LCD over here, which would be cos x. So this would become sine x minus sine x cos x all over cos x. Tip and times this, so times 1 over sine cubed x. Okay, over here I'm going to take out a common factor of sine x. So we get sine x into 1 minus cos x all over cos x multiplied by 1 over sine cubed x. Okay, so one of these sine cubes will cancel with that over there, and we are left with 1 minus cos x over cos x, and remember that's going to become sine squared, so sine squared x. All right, so what I'm going to do now is I'm just going to do like a little trick thing. If we have a look at the bottom over here on our right hand side, because remember this is what we're trying to get to, I've got here 1 plus cos x, okay? Also, I have the cos x over here and I have the cos x over there, so I'm happy with that bit. The only thing I need to do now with this side is introduce a 1 plus cos x at the denominator. Also, I need to cancel this 1 minus cos x up at the top because I've only got a 1 here. So what I'm going to do is I'm going to use my square identity again. We know that sine squared x plus cos squared x is equal to 1. Okay, that means that sine squared x, if I get it on its own, will be equal to 1 minus cos squared x, because I've just taken the cos squared to the other side. Now, if you have a look here, grade 11s, this is actually a difference of 2 squares. So we've got sine squared x will be equal to, if I factorize this, 1 plus cos x, 1 minus cos x. Okay, so if we factorized it. And that is what I'm going to replace this sine squared with this 1 plus cos x, 1 minus cos x. So over here we get 1 minus cos x over cos x. Now remember that this sine squared x is now going to be replaced with this, and we get 1 plus cos x, 1 minus cos x. This 1 minus cos x will cancel with that 1 minus cos x, and we are left with 1 over cos x 1 plus cos x, which is equal to our right hand side. And we have proved that identity. Okay, going on to the next one. Example C. We've got cos A, cot A. Cos A, cot A minus sin A, tan A, all over cosec A minus sec A. And we need to show that this is equivalent to 1 plus sin A cos A. Okay. So on the right hand side of this thing, we've got this 1 plus sin A cos A. Now remember what I said, you need to change everything to sine and cos. Now that's already in terms of sine and cos, so there's nothing we can really do with that right hand side. The only thing I can really work with here is the left hand side. Okay, so I'm going to change everything to sine and cos. So we've got here cos A multiplied by, now remember cot is cos over sine, so this becomes cos A over sine A minus sine A times tan becomes sine A over cos A. All right. Then this whole thing is divided by, now guys, I'm just going to write it just over here. Okay, but it should be on the side here. Now, your cosec is going to become 1 over sine A minus sec becomes 1 over cos A. All right. So let's have a look what's inside this bracket separately, divided by, and then we'll have a look what's inside that one then. So over here, we're going to get cos squared A over sine A minus sine squared A over cos A. Divided by, over here I'm going to find an LCD, and our LCD is sine A cos A. So I multiply this one by cos, and we get cos A, multiply this one by sine, so minus sine A, all over sine A cos A. All right. So let's have a look here. So I'm going to find an LCD for this one, and our LCD would be sine A cos A. So I need to multiply this one by a cos. So we get cos cubed A minus multiply this one by sine. So we get sine cubed A all over sine A cos A. This I'm going to tip and times. So times by sine A cos A all over cos A minus sine A. Right, so as you can see, this will cancel with that. And you're probably thinking, right, we can't go any further, but this over here is a difference of cubes. So I'm just going to do it on the side here. And you remember, if we have something like this, x cubed minus y cubed, what we would say that is, you would take the cube root of this, which is x, the cube root of that, which is y. The sign is the same. Then open up a big bracket, and then this is going to be x squared, y squared. This sign over here is always plus. Take this times this, which is xy, or sorry, minus xy, and then just change the sign. So it's plus xy, okay? And that is how I'm going to factorize this. So basically what I've done is I've just made cos and x a sine of y. And I've used the sum and difference of cubes to factorize it, okay? If you guys don't remember this, just have a look at one of my videos, my previous videos, and I'll explain how you do the sum and difference of cubes, okay? So I'm going to factorize this. and it becomes, I'm just having a look here, grade 11. So remember, x's are cos, y's are sine. So that x there will become cos A minus sine A. And then we're left with cos squared A plus cos A sine A plus sine squared A. All right, all over I'll put this straight again for you. All over cos A minus sine A. So this will cancel with that. And over here, we've got this cos squared A plus sine squared A. Remember from our square identity that sine squared A plus cos squared A is equal to 1. So those two become 1. And we get 1 plus cos A sine A, which is our right-hand side. Now, guys, these things are the same. Sine A cos A is exactly the same as cos A sine A, okay? So we've got here equals our right-hand side, and we have proved that identity. All right, going on to example D. We've got 1 minus sine x over cos x equivalent to cos x over 1 plus sine x. All right, so left-hand side, right-hand side. On the left-hand side, we've got 1 minus sine x over cos x. On the right-hand side, we have cos x over 1 plus sine x. All right, so grade 11, do you remember what we do? We change everything to sine and cos. But here's the problem. Everything is already in terms of sine x and cos x. So there's nothing we can really do there. But I have a little trick. What I'm going to do is I'm going to multiply by something called the conjugate. Okay, and the conjugate is just basically the opposite thing. Okay, I can either work with the left-hand side or the right-hand side. It doesn't really make a difference. For this, I'm just going to work with the right-hand side. So I'm going to multiply by the conjugate. So we're going to look at this bit here. So the conjugate of 1 plus sine x is 1 minus sine x. And what I'm going to do is I'm going to multiply the top by the same thing. Okay, 1 minus sine x. So basically, what we're multiplying by here is 1 minus sine x over 1 minus sine x is basically 1. So we're multiplying this thing by 1, so we're not changing it at all, okay? So up at the top, we will get cos x multiplied by 1 minus sine x over. If we have a look at the bottom here, we've got 1 plus sine x, 1 minus sine x. So that is like your binomial with binomial, but the signs are different. So remember that your outer and your inner terms will cancel. So all I'm going to do is I'm just going to do the firsts and the lasts. So 1 times 1 is 1. Sine x times minus sine x is minus sine squared x. Okay. And have a look what we've done here, grade 11s, is I've introduced this 1 minus sine x up at the top. All right, so I'm happy with that because I'm starting to get towards the left-hand side. The only thing I need to do with my right-hand side now is I need to cancel this cos x because we don't have one up there, and I need to get a cos x at the bottom. So what I'm going to do with this thing here, again, I'm going to use my square identity. And we know that sine squared x plus cos squared x is equal to 1. So I'm going to try and get this 1 minus cos x, 1 minus sine x by taking the sine squared x to the other side, and we get cos squared x is equal to 1 minus sine squared x. And I'm going to replace that 1 minus sine squared x with cos squared x. So we get cos x, sorry, there's an x here, cos x, 1 minus sine x over, now this is going to be replaced with cos squared x And 1 cos x here will cancel with that cos x. And just remember that was squared, so we still have a cos x at the bottom. So it's 1 minus sine x over cos x, which is our left-hand side. And we have proved it. All right, grade 11s. What I would like you to do now is the second part of the homework, which is this number 2 over here. Okay, so you can do those identities there for me. Okay, thanks guys.